We will now see how we can use select statement to pull data from different tables in Monet database. And for that, I will first create two tables. Now, I have already used these tables in the previous video, so if you have these tables in your database, you don't have to create them again, but I will create them again. So we will create a table with the name employees that has 4 rows, and I will also create table sales that has 6 rows of data. And now that we have our data, we will first start with a cross join. Cross join is a join between two tables where each row from the first table is combined with each row from the second table. So we would get something like this. Now this new table has 24 rows because for each row of the first table we have a combination with each row from the second table. So 4 times 6 is equal to 24, and that is why we have each row from the first table repeated 6 times, and total we have 24 rows. Now in this cross join, I have this column employee ID twice with the same name. But if I use a specific name for that column, for example, if we use statement like this one, where employee ID column is explicitly specified, in that case I would get an error because Monet wouldn't know from which of these two tables to get this column. And in these cases we have to make cross join by fully qualifying our column. So we have to use full name employees.employee ID, and in this case this cross join will work. I will now clear my screen. We have learned what is cross join, and cross join is a basis for all other joins. It is a basic join, but we can also use other joins, and we will now jump to this web page to see this diagram. And here we can see different kind of joins. We have inner join. With inner join, we would cross join all the rows from the first table and from the second table that are meeting some condition. In the left join, we would again use all of those cross-joined rows, but all of the rows from the left table, that is because of name left join, will be also mentioned if they are not already inside of cross-joined rows, and they will be filled with nulls because they don't have matching rows. And finally, we have full outer join. In this case, again, we are using all of the matching rows, we cross-join them, and then we will also add all orphan rows from the first table and all orphan rows from the second table, and then we will complete those rows with nulls. Now that we saw this, let's see some examples. I will go back here to terminal, and I will create one special cross join. Now this cross join has a filter, and this filter will include only rows where employee ID from the first table is equal to employee ID from the second table. So all other non-matching rows will be excluded, and this is by definition an inner join. For this, we also have this syntax that is different, but is creating the same result. And this syntax is much more understandable, much more explicit. Here we are stating that we are making inner join. Here is our condition, so we are using this clause on, and we would get the same result. And this is how we can understand connection between inner join and cross join. I will now clean my screen. Let's now see how we can create left join. For left join, we are using syntax like this. It is the same as syntax for inner join, just instead of inner join, we are using a left join. So if we run this, again, we would get all of those matching rows. They are here, they are cross-joined, but all the rows from the left table, and the left table is the one on the left side of this left join operator, so employees table, will be used with all of its records. So all of the rows from the employee table will be here, but those rows that are not having matching rows in sales table will be filled with nulls. And now we can easily see what rows from the employee table have matching rows and what rows do not have matching rows. Now, next I will show you full outer join, and for that, first I have to add one more row to this table sales. I need one more row, And now we can see how to create a full outer join. Again, we are using similar syntax. Instead of left join, we are now using full outer join. So when we run this, we would get the same result, just we have this one row more. And this row that I have added previously is here. So this is that new row, but this new row doesn't have matching rows in employee table, so this row will be also completed with nulls. In this full outer join, we have all of the rows from the both table, but only matching rows will be cross-joined. I will now clear my screen. In all of the previous examples, we have used the most simpler conditions, but it is also possible to use more complex conditions. Here I have a little bit more complex condition where we are asking for equality between these two columns, and we also want that the value of this column from the sales table should be equal to x. In these cases, it is wise to use aliases, and we can make our statement much more readable and shorter if we use aliases. And for table employees, we would use really short alias, just one letter A. For sales, we would use B, and if we have more tables, then we would use C, D, and so on. And this will make references to our columns much shorter, and everything will be much more readable. Besides using aliases for tables, we can also use aliases for columns, like in this example here. For table employees, we have used alias A, but we can also create aliases for its columns. So instead of employee ID, we would use emp number, and instead of employee, we would use name. So in this case, everything is working, just the names of these first two columns will be different. I will now clear my screen. It is also possible to join more than two tables. And to show you that, I will first create a new table with the name calendar. I will fill this table with some data, and then we will join three tables. We will join employees, sales, and calendar table. But before doing that, I will join just two tables. So I will repeat a statement that we have previously already saw. So I will run this statement, and this will join employees table and sales table. And then I will show you a syntax for joining three tables, and you will notice that we are just adding a new rows to our previous statement. So this part here is the same as this statement here. We are just adding more and more of joins, and this joining is done in a sequence. First we join two tables, we get this big table, and then we join another table to this big table. And this is how we just chain join all of our tables. So when we run this, we would get all of our three tables together. I will now clear my screen. In many cases, we're joining two tables based on a condition that says that some columns should be equal. And those columns could have the same name and the same data type in both tables. And we can use that fact to create some simpler syntaxes. And I will now start with ordinary inner join syntax. So this statement here is based on the fact that these two columns, employees employee ID and sales employee ID, should be equal. Now these two columns have the same name in both tables, and they are of the same data type. And this is the most used condition for creating joins, but we can use that to create a natural join. A natural join is just an inner join that is based on a columns that have the same name and the same data type. It doesn't have to be based on one column, employee ID. We can have several columns that exist in both tables, and result will be the same. And in this case, this natural join is assuming that we are using a condition like this one between all of the columns that have the same name and the same data type. I will now clean my screen. We have one more syntax that is based on the same principle as natural join syntax, but this other syntax is much more flexible. Let's start this time with the left join statement. So now we can use any kind of join. We can use left join, inner join, full outer join, and so on. But condition will again be used on equality between columns that have the same name and the same data type. But we don't have to base that condition on all of such columns. we can use only some of them. So we can list them here in using clause, and only those columns will be used to create a condition for join. And we can also choose what kind of join to use. So we can write left join, full outer join, or inner join. Now in this case, in these two statements, we are using the same join, and we are using equality between employee ID columns, so we would get the same result.